In this video, I'm going to go through the Specialist Maths Exam 1 for this NHT paper. So in front of me is a copy of the NHT paper, and I'll have a look at 9 questions. So the first question is regarding a position of a particle with respect to the origin at a time t seconds, t is greater than or equal to 0. So we might need to use that later. And it's given by the parametric equations x equals to 4t over t squared plus 1, and y equals to 2t, 1 minus t squared divided by t squared plus 1. X and y are measured in centimeters. Okay, the Cartesian equation of the path of the particle is given by x squared plus y squared equals to c. Find the value of c. So the left-hand side is x squared, which is 16t squared, divided by t squared plus 1 whole thing squared, plus 2 squared is 4, 1 minus t squared squared again, divided by t squared plus 1 whole thing squared. And then I'm going to combine these two fractions, say t squared plus 1 whole thing squared. The first term has 16t squared. The second term will have 4 lots of 1 take away 2t squared plus t to the power of 4 when I expand the perfect square. And then if I multiply out everything, I should be able to get, let's say, 4t to the power 4 minus 8t squared plus 16t, that is plus 8t squared plus a 4. Everything divided by t squared plus 1 whole thing squared. Then you may recognize there is a 4 in the front. So basically it's 4t squared plus 2t, actually t to the power 4, 2t squared plus 1. And then the bottom is just like t to the power 4 plus 2t squared plus 1. So eventually the numerator and denominator cancel out to be a 4. Therefore, the c value is 4 to answer the question. As the value of t approaches infinity, the position of the particle approaches to the point hk. Find the value of hk. Well, you are going to analyze some kind of limit. So I'm going to put the x and y equations here. So notice that this x is 4t over t squared plus 1. And I want to analyze the limit, but the problem is if I substitute the infinity here, and that's infinity squared, this is not quite, approachable within the current specialist maths study design. So what I will do is I'll multiply the top by 1 over t squared and also the bottom by 1 over t squared, okay? Then I'm able to get, for example, 4 over t divided by t squared times 1 over t, that's 1 plus 1 over t squared. Then if t approaches to infinity, my x is approaching to, the top part is like a 4 divided by infinity, that's a 0. The bottom is 1 plus 0, so that is approaching to 0 anyway. And also, just notice your y is equal to 2 minus 2t squared divided by 1 plus t squared. So you might want to say, okay, how about I get a minus 2t squared divided by 1 plus t squared. Then I can add a 4 back divided by 1 plus t squared. So instead, I'll get a minus 2 plus 4 over 1 plus t squared, okay? And then if my t approaches to infinity, my y approaches to minus 2 and plus 4 divided by infinity. Therefore, it's approaching to minus 2. So that is analyzing the asymptotic behavior of these two components. Eventually, my h approaches to 0, k approaches to minus 2. Okay? So that is the intended answer, I suppose. Before I attempt the next part, sketch the graph of the path of the particle for t greater than or equal to 0. I actually need to analyze the possible values of x and y, because it might not be, let's say, a full circle, because you can see the equation here is x squared plus y squared equals to c, but according to the possible values of x and y, we might not get a full circle. So what I'm going to say is, if you're going to analyze the behavior of x, well, I know if I have y equals to 1 over, actually, x over x squared plus 1, this function looks like, say, here and here, okay? It's called a wavelet graph. Therefore, if we have x equals to 4t divided by t squared plus 1, I may also get some kind of graph like this. And because I'm only looking at a t greater than or equal to 0, so I just need to look at, for example, this bit, okay? And we have a horizontal asymptote x equals to 0, but we do have a, x-intercept here. Next thing is I want to find this location. So if I take, let's say, dx dt, that is 4 times t squared plus 1 minus 4t times, let's say, 2t divided by t squared plus 1 all squared. Then I'm able to get, say, 4 minus 4t squared divided by t squared plus 1 whole thing squared equated to 0. I'm able to get, for example, let's say t equals to plus or minus 1. So the maximum is at t equals to 1. And if you solve 1 here, you get a 4 times 1 divided by 2. That is a 2. That's why all possible values of x will lie between 0 and a 2, okay? And also, if I look at, let's say, y equals to minus 2 plus 4 over 1 plus t squared. Let's say if I know the parental graph of 1 over irreducible quadratic is like a bell-shaped curve. Now I just have a dilation and then translate by 2 instead. So if I draw a quick graph, this is y, this is t, this is x, this is O, this is t. What I'm gonna get is like, okay, I've got an asymptote y equals to minus 2. And this is the maximum turning point, 0, 2. So I may just get a bell-shaped curve like that. And then I can see all the y values, this axis goes from minus 2 to 2, but this minus 2 is a, asymptote. And then I have my domain restriction. X is between 0 and 2. Actually, this is a square bracket. But eventually when it comes back to x equals to 0, approaching to it, then it's using part B, okay? And the y belongs to minus 2 to 2, inclusive, okay? Because we just take this part. All right. So eventually when it comes back to the circle, I only need to indicate, for example, here, 0, 2. Here, 2, 0. And here needs to be a hollow circle. So 0, minus 2, okay? And then you can just draw, let's say, a semi-circle around it. It's the right side of the semicircle, okay? If you have a pair of compasses, all I would do is like here. Okay, so on this line. Oh, I actually need to adjust my pair of compasses. Like this. Okay, so just this part. And if I draw that up carefully, and don't forget you need to indicate the direction using an arrow. So I think it's this direction. Okay, that's the direction of the path. Okay, so I'll move on to the next part. Let's have a look at our next page. The next page, I believe. Okay. Another confidence interval question. 95% of the confidence interval is this one, calculated for population mean using z equals to 2. Write down the sample mean. So the sample mean is just the midpoint between the two boundaries. There I have 52.65 plus 67.35 divided by 2. Just notice 0.65 plus 0.35 is 1, and 52 plus 67 is 190. So altogether, we have 120 divided by 2. That is like 60, if I'm not mistaken. And this is talking about the sample mean. So sample mean of what? Sample mean of, okay. Uh, okay, so it's the mass of the precious metal. Actually, selected cubic meter of soil. Actually, the unit shouldn't be meter cube, so just leave out the cubic, okay? Meter cubic. Find the population standard deviation used to calculate the confidence interval. So I'll draw a quick diagram here. So this is like the graph of the confidence interval. This is your X bar. This is your C lower, and this is your C upper. And this bit is called the margin of error, okay? Margin of error. So margin of error in specialist math is Z times the population standard deviation divided by N, okay? And we know Z value is 2 times, let's say, the population standard deviation divided by how many samples? 16 samples. So root 16 equals to the largest value, 67.35, subtracting 60. So you actually get a 2 divided by 4. That's a half. Half sigma equals to 7.35. Therefore, your sigma is twice as much. It's going to be 14.70, okay? The question didn't specify correct two decimal places or exact value, so I just leave that as a exact value, okay? Prove by mathematical induction that 2 to the power 3 plus 4 to the power 3 plus 6 to the power 3 plus ... until 2n to the power 3. So all the even number cubed and sum them up equals to 2n squared times n plus 1 squared, where n is natural number. So I would say n belongs to z plus, okay? For natural number, we start with n equals to 1. Now we call this one let Pn be this proposition, where n is natural number. Then we try the base case. We check the base case. P1 left-hand side equals to 2 to the power 3 equals to 8. And right-hand side equals to, let's say, 2 times 1 times 2 squared. That is also 8. Therefore, P1 is true. Okay, P1 is true. Now I'll have a look at the next step. Next step, I'm going to say the assumption. Assume PK is true, or K belongs to, let's say, Z plus, or K belongs to N. That we need to specify in an explicit expression or equation. So we say 2 to the power 3 plus 4 to the power 3 plus 6 to the power 3 plus infinite number of terms, and we have up to 2k bracket to the power 3 equals to 2k squared times k plus 1 squared, okay? It is important to use k here rather than using n. Otherwise, you are confusing the letters, okay? Then we carry out the inductive step. Pk plus 1, okay? We want to show this Pk plus 1 is also true for this pattern. So I'm going to say, okay, the left-hand side equals to 2 to the power 3 plus 4 to the power 3 plus 6 to the power 3 plus ... Once I get up to 2k to the power 3, I should also get, let's say, 2k plus 2. bracket cubed. The reason why it's not a k plus 1 here is because it's actually 2 bracket k plus 1 to the power 3. That generates 2k plus 2 to the power 3. You can see each time the item is like add 2, add 2, add 2, all to the power 3. And then you need to use, let's say, the right-hand side of the assumption. So we put a phrase here, use RHS of PK. So now I'm going to get a 2k to the power 2 times k plus 1 squared plus 2k plus 2 to the power 3. Then I'm going to combine these two terms. For example, I may just take out, let's say, a 2k squared, k plus 1 squared. Now, if I take out anything, I should be able to get a 2 to the power 3 times k plus 1 to the power 3. Then I can take out, let's say, 2 times k plus 1 squared. And I only have, let's say, k squared left. Then I should have a 2 to the power 2, which is 4 times k plus 1. Because I already taken out, let's say, k plus 1 squared. And then I'm able to get a 2k plus 1 squared. And this expression is k squared plus 4k plus 4. That is a k plus 2 whole thing squared. And this satisfies the pattern here, because if you compare, if I have a k here, there's a k squared here, there's a k plus 1 squared here. If I have a k, 2k plus 1 here, I should get, let's say, k plus 1 squared and also k plus 1 plus 1 squared. Maybe I should also write it explicitly. Let me just grab another color so you can see what I'm trying to show here, okay? It's k plus 1, k plus 1, plus 1. And that is indeed the right-hand side of pk plus 1. Okay. Therefore, pk is true, implying pk plus 1 is also true. By the principle of mathematical induction, if your initial case or base case is true, and the inductive step is completed, hence, Pn is true for all m belongs to z plus. Okay, so that is the way I would answer question 3. Okay, let's move on. Question 4. Show that tangent pi over 12 equals to root 3 minus 1 root 3 plus 1. 2 marks. So I would say, okay, tangent pi over 12 equals to tangent, for example, 15 degrees is 60 degrees minus 45 degrees. So I have a pi on 3 minus pi on 4. This is a very straightforward compounding formula. Then you just need to apply tangent pi on 3 minus tangent pi on 4 divided by 1 plus tangent pi on 3 tangent pi on 4. And that gives you root 3 minus 1 divided by 1 plus root 3 times 1, which gives you root 3 minus 1 divided by root 3 plus 1. And this is shown, okay? And consider the complex number z equals to root 3 plus I plus root 3 minus 1i. Express z in polar form. So this form should be written as RC theta, okay? Something along this line. And then probably it's related to part A because you can see the root 3 minus 1 and root 3 plus 1 here. So first of all, my theta is the tangent inverse y divided by x. So root 3 minus 1 divided by root 3 plus 1. And that is exactly the same ratio here. So that should indicate, for example, the first quadrant angle is pi over 12, okay? And then my r is going to be square root 3 plus 1 squared plus root 3 minus 1 squared. Something along this line. And then I should be able to get, for example, everything expanded and I try to simplify this expression. So we say 3 plus 2 root 3 plus 1 plus 3 minus 2 root 3 plus 1. And then I just cancel everything out. Cancel, cancel. So altogether, you have a square root of 8 or 2 root 2. So just be mindful, you need to answer the question. For example, your z should be expressed as 2 root 2 CIS pi over 12, okay? Next thing is w equals to z to the power 4. Show that w equals to 32 plus 32 root 3i. So w equals to 2 root 2 to the power 4, 6, 4 times pi over 12. And 2 to the power 4 times root 2 to the power 4 times 6 pi all 3, okay? So I'm explicitly showing the De Moivre theorem. And then 2 to the power 4 is 16, and root 2 to the power 4 is like 4 times 6 pi all 3. And this is 64, and 6 pi all 3 is like a half plus root 3 on 2i. Therefore, you would get, let's say, 32 plus 32 root 3i. By the way, the polar form of this complex number w is 64 6 pi all 3, okay? And lastly, on the complex plane, the origin O and the points representing the complex numbers z and w form a triangle. Calculate the area of the triangle. Well, probably if you want to get a good idea of what's happening, draw a diagram, okay? Draw a diagram and label these 2 points. Of course, the number 64 is very long, so I'm not able to, let's say, draw a very accurate to the scale diagram. But one thing I want to mention is if you have, let's say, complex number z is 2 root 2 6 pi over 12, so it's like a root 8. So maybe I have, let's say, somewhere here, this is my z, and this angle is pi over 12, okay? Then I rotate from, let's say, the horizontal positive x-axis, and then by this much, like 60 degrees, okay? Then I'm able to get something like this. So this point is my w, and this large angle is going to be pi all 3. Therefore, I can figure out, let's say, this angle here, and that is 60 degrees minus 15 degrees, 45 degrees. I've got a pi all 4 here. Eventually, you are able to form a triangle like this, OZW. By the way, this one is not a right angle triangle, okay? So just recognize this length here is like 64 coming from part C. And the other length, we calculated the length of complex number Z. So like this is 2 root 2, okay? Therefore, I can use an area formula for the triangle half BC times sine A, etc., or a half AB sine theta. So the area triangle OZW equals to half times 64 times 2 root 2 times sine of pi over 4. Eventually, 2 and 2 canceled out. We have 64 root 2 times 1 over root 2. So the answer is meant to be 64, I suppose. So that is the whole question 4, right? All right, moving on. Question 5. Quite a bit working. The growth of a population of bees is modeled by the logistic differential equation dB dt equals to 0.03 b times 1 minus b over 500, where b is the number of bees after t weeks. Initial population b naught is 200. Use integration to show that t is this expression. Okay, so you can see it has 4 marks. Quite a bit working. Before I do that, I'm actually rewriting this differential equation a little bit. That is the b dt equals to 3 over 100 times b times, well, I may want to combine these two parts, like I write it like 500 minus b divided by 500, okay? And then I'm going to separate the variable, like I multiply, let's say, dt here. And then I just divide the b times 500 minus b over 500 over the other place. So I should be able to get, for example, 500 divided by b times 500 minus b db equals to 3 over 100 dt, okay? And then I just integrate both sides to solve this differential equation. By the way, you have 4 marks here. Enough working should be demonstrated. To show an explicit integration, I probably need to use the partial fractions. Say 500 divided by b times 500 minus b. That is some kind of, let's say, some a divided by b plus small b divided by 500 minus capital B. So you have a times 500 minus capital B plus small b times capital B equals to 500. Therefore, if I sub b equals to 0, I'm able to get, say, 500a equals to 500. So a equals to 1. And if capital B is 500, I've also got 500 small b equals to 500. So the small b is 1 as well, okay? Then I can just carry out my further working down the track, okay? By substituting the partial fractions into the left-hand side and integrate both sides. So the next thing is, I'll be able to get, say, integral 1 over capital B plus 1 over 500 minus b db equals to 3 over 100 t. And I'll add an integration constant to this side, okay? I haven't obtained the antiderivatives yet. So the antiderivatives will be log e capital B minus log e 500 minus b at c equals to 3 over 100 t, okay? The next thing is I'll use the initial condition. T equals to 0, B equals to 200. By the way, I didn't involve absolute value here because B naught equals to 200. Therefore, capital B is supposed to be greater than 0, and then 500 minus B is also greater than 0. Okay? If the initial condition has the value larger than the capacity 500, then I probably need to, change the size, etc. So then I should be able to get log E B divided by 500 minus B at C equals to 3 over 100 T. And then T equals to 0, B equals to 200. So therefore, I'll get a log E 200 over 300. That is 2 on 3 at C equals to 0. So C is negative log E 2 on 3, and that is log E 3 on 2. Eventually, I found this C, and I put this back to put them together. Therefore, 3 over 100 T equals to just 1 log E term, like B times 3, 2 times 500 minus B. So we say 3B divided by 2 lots of 500 minus B. And then T equals to 100 divided by 3 log E of 3B divided by 1,000 minus 2B. Okay? I'm glad this question didn't ask for rearranging like a 14B in terms of T. That will be another layer of consideration, but I'll just stop here for part A. Then find the value of t for which the population is increasing most rapidly, which is looking for the point of inflection on the graph. So if you quickly draw a diagram like this, for example, this is t, this is the origin, this is the number of these. Your initial condition is here, 200. The capacity can be identified by equating your derivative ddt to 0. So this is b equals to 500. And where would I get the point of inflection? Well, at 250 somewhere. So the graph might look like this, okay, initially, and then get a point of inflection. To recognize that, you can use the symmetry of this quadratic in terms of b, like the midpoint between 0 and 500 is 250 to attain a maximum value of the gradient, okay, which is the steepest gradient here. And then my t is just 100/3 log e of 750 sub b equals to 250. 750 divided by 1,000 minus 500. That is 500. Okay. Of course, this value can be further simplified. For example, 75 divided by 50 is like 3/2. So you get 100/3 log e 3/2. The unit is like weeks, okay, t weeks. Okay. Value of t, population is increasing most rapidly. Initial position, show that. This is the answer we want. Okay, let's move on. Other few things to go. All right. This question. Consider the lines L1 and L2 with respective equations. R1 is 1 minus 2, 4 plus t times 1, 3 minus 1. R2s is 0, 3 minus 3. It doesn't have a I component for the reference point. And this is another direction vector. So show that L1 and L2 are skewed. That is, they do not intersect and they are not parallel. Okay, so what I'm going to do is I'll try to, for example, argue from the velocities. Consider the direction vectors V1 equals to I plus 3j minus k. And V2 equals to 2i plus j plus 4k. Now, let V1 equals to alpha V2, something along this line. Then we get, let's say, 1 equals to 2 alpha, alpha equals to half, and alpha equals to 3, and also 4 alpha equals to minus 1. Therefore, alpha is minus 1/4. Not consistent. You can see the 3 alpha values are not consistent. Therefore, L1 is not parallel to L2, okay? Something along this line. Then, if you want to show they do not intersect, you have to show algebraically, okay? Bear with me. For example, consider their potential intersection point. The I component, we have 1 plus t equals to 0 plus 2s. And the j component, we may have, let's say, minus 2 plus 3t, minus 2 plus 3t, equated to, let's say, 3 plus s. Also, the k component, we have 4 minus t equals to minus 3 plus 4s. Naturally, I would get, for example, this is 2s equals to t. 2s equals to t plus 1. And if you notice, oh, there is a t and a minus t, so let's name them as 1, 2, 3. Then you might want to say, for example, 1 plus 3 gives you 5 equals to negative 3 plus 6s. So s 6s equals to 8, and s equals to 4 over 3, if I'm not mistaken. And if you sub that into, let's say, the first equation, you actually get, let's say, 1 plus t equals to 8 over 3. And the t equals to, for example, 5 over 3, if I'm not mistaken. Okay, now I want to check if the t and s value will also satisfy 2. Check Ts with equation 2. For example, the left-hand side is now minus 2 plus 3t, that is 5. That's equal to 3. And the right-hand side is 3 plus 5 on 3. Here is the problem, which is not equal to the left-hand side. Apparently, it has an extra bit beyond 3. Therefore, we can't find a common pair of Ts values to satisfy all 3 equations. No point of intersection. So that's why L1 and L2 are skewed. You can see the 2 marks. 1 mark is for showing the 2 direction vectors are not parallel to each other. And another mark is to show one set of suitable working to prove the 3 equations are inconsistent. Okay, you might have other methods. For example, I don't think it's a very efficient method. Suppose you are learning linear algebra at a 3-4 specialist math level. You can use, let's say, the reduced row echelon form, etc., to argue this system of equations is inconsistent, etc. Now, I'm not going to go overboard. The next thing is we want to find the shortest distance between L1 and L2. So just like a diagram like this, we need to get a common normal vector. Say this is V1, this is V2, V2. So we take a cross product, and then we need to pick, let's say, 2 points. Pick 2 points. Let's say this is A, 1 minus, actually 0 plus 3 minus 3. Let's say this is L2, this is L1, this is B. For example, 1 minus 2, 4, etc., etc. Okay, you might want to do BA or AB, doesn't really matter. Anyway, so according to my diagram here, I should be able to get, let's say, vector A to B. It's 1 minus 0, 1i minus 2, take 3 minus 5j, if I'm not mistaken, and then 4 minus negative 3 plus 7k. Okay, and then if I take a normal between V1 times V2 or V2 times V1, etc., etc., should be able to get, let's say, a perpendicular vector. So if I have V1, 1, 3, minus 1, and 2, 1, 4, I should be able to get I times 3 times 4 is 12 minus negative 1. Subtracting j, 1 times 4, 4, take away negative 2, plus 2. K, 1, take away 6. So eventually I should be able to get a 13i minus 6j and then minus 5k. And the shortest distance here, we want to take a scalar resolute of AB upon n hat, okay? So the shortest distance is given by AB dot n hat magnitude. Therefore, I make it 1 over magnitude of n times the absolute value of AB dot n. Okay? AB dot product with the unit vector n. So AB dot n, let's calculate the magnitude. That is 1 times 13, 13, and then we have plus a 30, minus 35, if I'm not mistaken. Is that correct? Let me have a closer look. You should have a 43 minus 35. That is like 8. Okay. I should also have a look at this one. And then the magnitude of n is square root of 13 squared, 169 plus 36 plus 25. So you will get, for example, square root of, this is like 205 plus 25. So it's a square root of 230, okay? And then we can just chuck them into the formula and see what's happening, okay? Okay, so the shortest distance equals to 8 divided by root 230. And you might want to simplify this one. You can get 8 root 230 divided by 230, and that will be 4 root 230 divided by 115. Something about this line, huh? That's strange. Anyway, let's move on and look at the other part. Okay, a toy car travels along a straight horizontal track. At t equals to 0, the toy car starts from rest. Part A wants me to sketch a diagram. At a line O, and accelerates with a positive constant acceleration until it reaches a velocity of 10 meters per second. So not entirely sure where is that, but it is then undergoing a constant acceleration of minus 4 meters per square second until it attains a velocity v of minus 2 meters per second. Finally, the toy car accelerates with a constant acceleration for 2 seconds until it arrives at a line F with a 0 velocity at a time tf seconds. Line O and F are perpendicular to the track. Eventually, I know it's coming back to here. Let me have a look. Okay, the acceleration of the toy car is positive for twice the amount of time that the acceleration of the toy car is negative. Show that it takes 9 seconds for the toy car to reach line F from line O. Okay. So the total amount of time here, I would say it's 90. And with constant acceleration for 2 seconds until it arrives. Okay, from minus 2. I would say, okay, let's just take, let's take 2 seconds back. Okay, 2 seconds back, etc. Okay. So this is a 7. And this is actually accelerating from minus 2 back to 0. And at some stage, I should be able to get, let's say, a 10, but I'm not entirely sure where is that. So I'm just choosing a random point. So, okay. This is up to velocity 10, okay? Up to velocity 10. Let's call this TA. TA, T acceleration, and then deceleration of -4, etc., etc. Hopefully that's the required velocity time graph. And so the next part, the acceleration of the toy car is positive for twice the amount of time that the acceleration of the toy car is negative. Okay, show that it takes 9 seconds for the toy car to reach line F from line O. Okay, so I'm going to refer to what's happening here. This is actually TF -2. If I didn't assume this is a 90, okay? And from TA to TF -2, this bit of time, decelerating time, is TF take away TA take 2, okay? The difference between these two values. And the accelerating time, I'm gonna find another color pen, is rounding out the colors. Right. Yeah. This bit is 2 seconds. And this bit is, let's say, TA seconds. So TA plus 2 equals to twice TF minus TA minus 2. That is the first thing I'm going to use, okay? TA plus 2 equals to twice TF minus TA. Take 2, all right? And now, the other thing is we have two unknown variables. We need to find another condition. So for example, over this period of time, the acceleration is -4. Okay. So I might say, okay, when t equals to TA, the velocity is actually, let's call this u equals to 10. When t equals to tf -2, my v equals to -2. And the acceleration is -4. So I'm going to use v equals to u plus 80. Okay, something along this line. And then -2 equals to 10 -4 times yeah, I need to take the difference as well. Okay, I need to take the difference. So for example, it takes TF minus TA minus 2. Okay, the difference between these two types. And then I probably can use, for example, these two equations. Let's just tidy them up. For instance, I should get, let's say, -4 equals to -12. So TF minus TA minus 2 equals to 3. And TF minus TA equals to 5, something along this line. And then this is my first equation. This is my second equation. I'll solve the second equation into 1. The second equation into 1 gives me TA plus 2 equals to 2 lots of 5 take 2. That is like TA plus 2 equals to 6. Therefore, TA equals to 4. So eventually, TF is 4 plus 5, and that is 9 seconds. Okay? Quite a bit working for 1 mark. Show that equation, to be honest with you. And then we want to show that the equation for the velocity of the toy car when it has a negative acceleration is given by v equals to 26 minus 40. So we know acceleration equals to -4. At t equals to, for example, TA equals to 4 seconds. The velocity was 10 meters per second. And then we say V equals to minus 40 at C. And then just submit 10 equals to minus 16 plus C. So therefore C equals to 26. So V equals to 26 minus 40. You might also argue from the constant acceleration formula, just show your substitution and rearranging to this equation. Here I just show the one step, very simple integration anyway. And lastly, show that the displacement of the toy car from line O when it reaches line F is 30 meters. I probably need a diagram. Let me just draw a quick diagram. Okay, that's the diagram. This is 9 seconds. Takes 4 seconds. And this is to 10. This is to minus 2. Okay, so let's go. Yep, that's one part. And this is 7. Up to here, minus 2. Almost a line, okay? So I know this section has the rule, the VT graph has the rule 26 minus 40. Therefore, I'm able to find, okay, along this section, when is the velocity 0? So this is like t equals to 26 over 4, which is like 6.5, I suppose, 13 over 2. And then this region delta t equals to 2.5, okay? And this is minus 2. Just be mindful. The area under the VT graph is the displacement, okay? Is the displacement. The blue region I indicated here has a positive displacement from 0 to 6.5. And from 6.5 to 9, that is like a negative region. So I want to find, let's say, the sum of the two sine area. Then we say the total displacement equals to half times 6.5 times, let's say 10, minus, the reason why I put a minus is because this is a negative displacement, minus half times 2.5 times 2, okay? That's the height of the triangle. Just use the triangles. Then you will get, let's say, 6.5 times 5 minus 2.5. So you actually get a 32.5 minus 2.5, which is like 30 meters. Okay, 30 meters. Yep, that is pretty much this part. And finally, a toy train moves with a constant velocity on an adjacent parallel track, such that the toy car and the toy train are at line O at the same time, and both arrive at a time F at the time TF. That means they have equal amount of time and equal displacement eventually. But what I want to say is, okay, how could they have the equal displacement? Here is a constant velocity. The total displacement equals to 30 meters. TF equals to 9 seconds. Therefore, the constant velocity of the train is 30 over 9, which is 10 over 3, okay? So I'm going to plot this graph on the same diagram here. Let's say this is 10 on 3, this is 20 on 3. So for example, it should be up to here, okay? Up to here. You just ignore this bit. And then I want to find a particular moment where the triangle area equals to the rectangle. Okay? By the way, if you know this t value for the acceleration stage is 4, for the toy car, the acceleration equals to 10 divided by 4, which is 5 on 2. Therefore, the velocity is 5 on 2t, and x toy car equals to half times 5 on 2 times t squared, okay, because it's accelerating from the rest. Let t be the first value when the toy car and the toy train have the same displacement. I'll use another phrase to draw level. Draw level means they are at the same position, okay? So I'll get a 5 over 2t squared, actually capital T, okay, capital T, equals to 10 over 3 capital T. And then I can divide the 5 both sides to get a half t squared minus 2 on 3. Actually, this is a 4, not a 2, okay? This is a 4, right? 4. T equals to 0, so I can take out a t and then get a quarter t minus 2 on 3 equals to 0. T equals to 0 or t equals to, let's say, 8 on 3. Knock out this one. This is where they start. So therefore, the required time t equals to 8 over 3, etc., etc. Okay? Seconds. All right. This is a very, I would say this one is a very challenging kinematics question. It's not in terms, the level of difficulty is not in terms of the algebra. It's actually the part you need to comprehend everything, okay? Quite a bit to read through here. Okay, question 8 and question 9. I think that's it. Surface surface area of revolution. Okay, so now I just use the formula about which axis? S equals to 2 pi from 0 to half pi. We should have an x here, and then x dash theta squared plus y dash theta squared, and d theta, it's 2 pi from 0 to half pi, and you should have, let's say, 4 cosine to the power 3 theta. And if you differentiate in both parts, you will get, let's say, 12 cosine squared theta times negative sine theta. That's one part. Don't forget a square here. Plus, let's say, 12 sine squared theta cosine theta squared. And then I should be able to get d theta, right? And don't forget the chain rule here where you differentiate x and y with respect to theta. And then I'm going to get, maybe I should write an 8 pi instead of, 2 pi from 0 to half pi. I have a cosine cubed theta here. And 12 squared, take it out. And then you should have a cosine to the power 4 theta sine squared theta anyway, plus sine to the power 4 theta cosine squared theta d theta. Okay. And then this 12 squared square root will be 12. So I can bring out the 12 to get a 96 pi, 0 to half pi. We have a cosine cubed theta here. And then for these two terms here, looks like we have a common factor. For example, cosine squared, sine squared as a common factor. Then you just get a cosine squared theta plus sine squared theta d theta. And eventually, cos squared plus sine squared is 1. This is equal to 1. So you can knock that out. And then the domain is 0 to half pi, which is like, okay, first quadrant, first quadrant. So both of them, sine and cosine, has to be positive. So I don't need to worry about, let's say, the absolute value. Eventually, it's 96 pi from 0 to half pi. And cosine power 3 times cosine power 4 theta times sine theta d theta. You might want to make a substitution here, but I don't think it's very helpful. You say let u equals to cosine theta, your du d theta equals to minus sine theta, etc. Okay? And then the integral from theta values to the u values. If theta is 0, that is 1. If theta is half pi, that is 0. So actually, I'm not using this notation. So u equals to 1 to u equals to 0, okay? So that's a 96 pi from 1 to 0. We have a minus u to the power 4 du. The reason why it's a minus is because this is sine theta times d theta. It has a negative here. And then you just get a 96 pi 0 to 1 u to the power 4 du. So effectively, you get a 96 pi over 5 u to the power 5 from 0 to 1. Therefore, you get a 96 pi over 5. That's the final answer. I think this is a very familiar question. Yeah, very familiar question. Let's have a look at the last one. Show that arctangent root x is x times arctan root x minus half root x1 plus x dx. And hence evaluate the definite integral. Okay, it's lovely to see them breaking the integration by parts into two sections. So if I want to show the given result here, I'll say let u dash equals to 1, u equals to x, and v equals to tangent inverse of root x. And v dash is going to be 1 over 1 plus root x bracket square times 1 over 2 root x. You have to show the chain rule here, okay? So effectively, it's just a half times root x divided by 1 plus x, okay? Therefore, integrating u dash v dx equals to uv minus uv dash dx. And that is x tangent inverse of root x subtracting, let's say, a half times, actually, sorry, bear with me. This one is not yet root x. This is actually 1. This is a root x here. We have a half indeed, but then we have 1 over x plus 1 root x times x, because that is my u times v dash dx. Then this x cancel the root x here to give you x tangent inverse root x minus a half integral root x divided by x plus 1 dx. That is equal to my right-hand side. Okay, so that's completely shown. Hence, evaluated 1, 2, 3 arctangent root x. So from part A, this integral equals to x tangent inverse of root x from 1 to 3, subtracting a half integral 1 to 3 root x divided by x plus 1 dx. So I'll call this integral, let's say, I2, okay? The first calculation I can write 3 tangent inverse of root 3 minus 1 times tangent inverse of 1. but then I will subtract an I2, okay? I'll worry about the I2 later. So I should get a 3 times pi on 3 minus 1 times pi over 4. So eventually I should be able to get, let's say, a 3 pi over 4, something like that, okay? Don't forget you need to minus I2. I haven't calculated the I2 yet, so this is minus I2. So that is like a pi minus pi over 4. So 3 pi over 4 minus I2. Okay, but I'm not stopping here because consider I2 equals to a half integral 1 to 3 root x divided by x plus 1 dx. We need to make a substitution here. Otherwise, I can't really see how you're going to integrate this expression. So we say, okay, let w equals to square root of x dw dx equals to 1 over 2 square root of x. So dw times 2 root x equals to dx. The purpose of doing this is because I want to change the dx in terms of dw. And I also notice my dx can be written as dw times 2 root x, which is 2w. So 2w dw. If x equals to 1, my w equals to 1. If my x equals to 3, my w equals to square root of 3, something along this line. Okay? And then I can just calculate everything like a half. This is w equals to 1, w equals to root 3. This is my w divided by w squared plus 1 times 2w dw, okay? Something along this line. And then you can cancel the 2.5. Eventually, you just get 1 to root 3 w squared divided by w squared plus 1 dw. And you can split that in this form, like 1 to root 3 w squared plus 1 divided by w squared plus 1 minus 1 over w squared plus 1 dw, something along this line. And you get 1 to root 3, 1 take away 1 over w squared plus 1 w. So this result will be a w minus a tangent inverse of w, 1 to root 3, okay? And then you will get, let's say, root 3 minus 1, that's the first part, minus tangent inverse of root 3 minus tangent inverse of 1. So you actually get a root 3 minus 1 minus pi on 3 minus pi on 4. So you actually get a root 3 minus 1 minus pi on 12, okay? And just be careful with the plus or minuses. Therefore, my initial I naught, therefore I naught equals to 3 pi on 4 minus I2. That is minus root 3 minus 1. Take away pi on 12. So you actually get a 9 pi over 12 plus, minus minus plus pi on 12 minus root 3 plus 1. Eventually it's 10 pi over 12, which is 5 pi over 6 minus root 3 plus 1. Okay, so that's the problem solved. Well, to be honest with you, I didn't expect it took me so long to complete this specialist math exam 1, even though it only contained 9 questions. And it does ring the bell. You have to be fully prepared for this big chunk of algebra. And also, don't be too surprised if you see a question like very lengthy multi-pass question on exam 1. Okay, yep, should be all good now. Hopefully I didn't make any silly mistakes. I'll see you in another time, and all the best for your exam preparations. Bye.